Assalamualaikum and good day. Guys, today we're going to discuss on our problem solving for real-time operating system.
Okay.
So, my name is Farizul Imran and I'll be talking about RTOS, the real-time operating system that we've chosen to compare. So, for RTOS, it is a real-time real-time operating system, which is open source for embedded systems. So PRTS started when Richard Berry worked on it since 2002. So what's special about PRTOS is that it is designed to be small and simple. It is mostly written using C programming language, but it also has a few assembly language functions when necessary. And compared to the other OS, it is much more simpler, but it also has its own unique features which have been developed over. So next, the UCOS, I think, Arif can say.
Okay, so can you guys hear me?
Yeah.
Yes. Okay, I'm Arif and I'm about to explain for the UCOS2. So basically, UCOS2 is a priority-based preemptive real-time operating system. And in the real-time system, the application design process is divided into multiple tasks. And each task has its own priority. The priority is the unique identification of the task, and they run in coordination under the scheduling of the operating system. So the UCOS2 requires hardware to provide a stable clock source, and interrupts occur periodically in order to work normally and perform corresponding task scheduling, or as time tick makes the task hold delay time expires ready. Otherwise, the task delay number is decremented by 1, and OS INT finds the highest priority ready task, resume it, and schedule task through SINT SW. Okay, so that's all for me for the UCOS2 definition.
Alright, okay, so it's my turn now. Okay, my name is Mubarak. So now I'm going to explain about the free RTOS coding. So for this problem solving for, we chose free RTOS to compare with UCOS2. So let's go to the code. Okay, like any C programming, we include the standard one, the standard library for C programming, and then we also include all the kernel that are required for free RTOS. So this is only unique for free RTOS. Okay, and then the next part is that we define the main number of tasks. So we make it 10 for now. This one, okay, I'll explain this one a bit later. Okay, this one is for the task data in the task function. Later I will explain it. Okay, now this is this line of code is we declare the semaphore. So for free RTOS, the semaphore is called binary semaphore, which means that the available resource in the semaphore, it's either 0 or 1, which means 0 is there's no available resource, and if 1, then only one resource available. So which also means only one task can run at one time. Alright. So okay. So this is the task that we declare. This the implementation will be at the bottom. So let's skip this one for now. Okay. Right. So this is the main LAST-SEM function, which we call we initialize the binary semaphore here. Binary semaphore equal to x semaphore create binary, which means we are creating the semaphore binary to this variable. So as long as the binary semaphore is not equal to null, it will execute all this function. So this function will create the task, create task, this one. So okay, so this is the name of the that the name of the task that we are going to create. So for free RTOS, if we want to create a task, we call this function, which is x task create. So we give it a name, and then this one is just for testing. This is, I'm not sure what it is. And then this one is the parameter which we passed to the function, but now it's null. So we make this priority 0, so it will be the first task that will be run. Alright, so okay, so okay, this one that I skipped earlier. So this function, this one is according to the documentation, this function it simulates an interrupt behavior. Okay, let's go to the function. Okay, this one. UL example instruct handler 1. So what this basically this function will like interrupt the task. I mean, oh no, it will initially one task will take the semaphore. So this one will interrupt that task and will, if the task that took the semaphore earlier done the task, this function will get the semaphore back from that task and will give it to the next task, something like that, according to the documentation. I'm not really sure what is that. Okay, so then okay, yeah, I've explained this one. Okay, okay, for this one it means that it'll, for example, like for where is it? Yeah, for users, they use OS start. So for FreeRTOS, we'll use task start scheduler. Yeah. Okay. Let's move on. Create task. Create task. So this task will create the number of the tasks according to the number of tasks that we declared earlier at the top. This one. Yeah. So basically, this will only create. You can see here. This will create this vtask function. Yes, and it will pass the task data array to the vtask. This one. Okay. And then yes. Okay. Next function is vtask. So this is where the numbers will be shown. So the random numbers and the this task data, the parameter that we passed earlier, will show the numbers. So this one only just to delay the numbers. I mean to delay the print. Okay. So this one, this semaphore take means that we take the semaphore resource from this one, from X binary semaphore that we create earlier in the main LAST-SEM. And this one, port max delay is means that it will delay the task indefinitely until there is some resource available, or one resource available in the binary semaphore. Okay, so let's try to run the coding. Okay, okay, sorry. Okay, this is the result when I run the coding. It will display the random numbers, and it will run indefinitely until I stop it. So yeah, this is what happened. Okay, move on. So if
This one is running 5 identical tasks.
10
Okay.
10 identical tasks. So let's say I pause the task now. We can, if you can see here, yeah. So this is the CPU usage for the task, for this task, for this coding. So it shows that it's using 78.2% for the kernel, and then the rest for others. Okay, let's stop this. Maybe we can try to we can try to make it 15. Let's run it. Okay. As you can see, it will show the ASCII ASCII characters. Yeah. This one shows for the, I think it's 10 until 15. It will, yeah, same like before, but it will show the ASCII characters. Okay, and then okay, let's pause task, and let's see the CPU usage. Okay, so for that one, it uses 77.4% of the for kernel, and 70.6% for IO, and then others. Yeah, I think that's all from for free RTOS code. Maybe Caleb can proceed for UCOS.
Okay. I share screen.
All right. Okay. Let me stop sharing. Yeah. Okay.
Can you all see my screen?
Yep.
Yeah, can.
Yep.
So now maybe I follow the lab exercise. So here stated change from 5 to 15, the identical task. So I open the test.c, then I change to 15, and then I compile the code first. In one.
Make test.c.
Lemak.
Oh, typo.
CT. Okay, after compiling the code, and then wait for a while, and then let's execute the test. test.txt. So we can see the result here. You all can see, right? The
Yep.
task is
Yep.
30, CPU usage is 69, and then the task switch is 2202. Okay, move on to the next one. To see what happened, open the file OS CSG, and then increase the number by 5. So I change the OS max task and lowest prior. OS max task increase by 5, 16, and then 17. Okay. And then recompile again. And then execute. We can see that just now the task is 13, and then the CPU usage up to 100.
Oh,
And also and also the task is increased, is double up. You can
I see.
Okay, so write out the difference, and then we can record it in the report. So next one is the key symbol. Here is the ASCII table. So from here for the number 0 plus 1, so we can see 0 is number 48, and then down to 9 plus 1, 2, 3, 4, 5, 6, 7, 9, 10. 10 is this one, this column, and then semicolon. This one is for 10, 11, 12, 13, 14, 15, I think.
Okay.
So later we can include this in the report.
All right.
Okay.
I think that's all from me. Thank you.
Okay.
Okay, bye-bye.
Wait, hold on.
Yeah.
Okay, so let's compare the code. Let's hold on. Compare the code. Wait, let me share my screen first. All right. Can you see my screen?
Yep.
Yep. Can.
Okay. Hold on. All right. Okay. Can you guys see the code? Is it visible to you?
Left hand side is the free RTOS.
Yes. Free
Then
RTOS.
right
Right
hand side is UCOS.
Yes. Okay. So to compare, let's see. What should we compare first? I think this one, we just include and declare. Maybe we can compare the maybe. Hold on. It's not. It's okay. Okay. Yeah. Right. Okay. So I think for this one, a lot of differences. So if you can see the UCOS use this syntax for semaphore. So for the FreeRTOS is not a little bit, a lot of different. And then So this one is the random number. So I created it like this. This one is like this. So for others, if I'm not mistaken, this one means that it will it will make the resource available back, right? This one is take the from semaphore, and then this one will give back to
Release
semaphore.
it.
Release the resource back, right? Yeah. So for free RTOS, it's different. So if you can see here, this one is take, which means we take from the semaphore if it is available, if the resource is available. So to give it back, that's why I create the that's why I put this here. So according to the documentation, this function, this function, it it might make the interrupt, because free RTOS we are using the Windows port, so we are using the software to interrupt the task. So it's not it's not the same as when we are using hardware. So that's why according to the documentation, this function is enough to mimic the interrupt task. You guys understand?
Yeah.
Okay. So if you can see here, this one, semaphore gift from ISR. So it means that literally it gives the semaphore to unlock the task. So another task can use it. So another task can use it and run the code. Okay, so that's one different. I mean that one. That one is one different. Okay, so so for delay, I think this one is delay. This one is so for PRTS we use this syntax. We task delay, and we use 100 here, and this one is this syntax. Okay, so for printing the numbers, for free RTOS, we just use printf. So for UCOS, maybe this one is from the UCOS library, maybe, I'm not sure. Okay, and then like I said before, for free RTOS, if we want task, we use X task create. Whereas for UCOS, OS task create. The difference at the front only, and also the parameters here, so a little bit different. Okay, yes. What else what else the difference? Okay. Okay, this one, if we want to start all the tasks, we use for UCOS, we use OS start. So for free RTOS, they use this function, vtask start scheduler. Is there anything else that you guys I think that's all, right?
I think, for the coding.
Yeah, I think so. Because I did the free RTOS according to the documentation, so yeah. All right. I think that's all from our group.
Yeah, I think one more that we have to compare, use the table to compare the features.
Yes. Yes, correct. We need to also include that in the report.
Okay.
Yeah. Anything else?
I think that's all.
I think that's all.
Yeah, I also think that's all. Caleb, anything you want to add? Okay. I'll take that as a no. Okay, right. So yeah, that's all from our group LAST-SEM. Thank you very much.
Okay, thank you, guys.
Thank you.
Okay, thank you. Bye bye.